Hey guys, in this new video, we're going to take a look at how exactly do we name alkanes. So, naming alkanes, naming of any organic molecules comes with a set of rules that you need to remember. Now, here we're going to say when naming any alkane compound, there's a set of rules you should follow to get the correct answer. So here, first you have to find the longest carbon chain and assign a root name accordingly. So basically what I mean by root name is it's an alkane, so the root name octane, or propane, or butane. If there's a tie between longest chains, choose the chain that gives more substituents. So substituents are just branching groups. So substituents are the groups that branch off of the main chain and weren't counted as part of the main chain. Next, you're going to number the chain from the end closest to one of these substituents. Substituents will be named alphabetically, and a number will accompany the location of their attachment. We'll see how that works. If more than one of a similar alkyl group is present, then we must use numerical prefixes to describe the number of them. So let's say you had two methyls on your compound. You would say that you have two methyls, so it's dimethyl. Let's say you had three methyls, then it would be trimethyl. 4 would be tetramethyl. And 5 is not really that common, but it would be penta. So, remember, every edge here is a carbon. We're trying to find the longest carbon chain. So we can look at it in different ways. We can say, okay, let's say that this is my longest carbon chain here. Right? Look, see how many that has. It has 1, 2, 3, 4, 5, 6, 7, 8, 9. So far, that looks like the longest. Okay, let's try to count a different way. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That definitely is a longer chain, so this is out of the running. Now, at this point, this is as difficult as it could ever get. This is a pretty advanced example that I'm showing you, but when you get to organic, I know I'm saying this a lot, these are going to become typical types of questions. So it's going to become important, guys, that you basically go through the rules that we just talked about in order to organize your thoughts and best approach the molecule to get the correct answer. So far, that looks like the longest. How else could I look at it? Well, I could look at it maybe like this. That doesn't look like it's going to beat it. 1, 2, 3, 4, 5, 6, 7, 8. Nope, not going to beat it. That's not a good alternative. What about this way? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that the longest? Looks like that might be the longest. Yeah, 11 looks like it's the longest here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. That looks like it's the longest chain there. So this chain that's made up of 11 would be our winner. Now, technically, we didn't talk about 11 carbon chain, but the name of an 11 carbon chain would be undec for 11 carbons, and it's an alkane, so it's undecane. Now here we want to number it from the end closest to a substituent. What's a substituent again? Basically these carbon groups that didn't get numbered. So here this carbon group has 2 carbons on it branching off. So this is an ethyl. These each have only 1. So these are methyls. And this one here has 4 carbons, so this is a butyl. We got to number it from the end closest to one of them. So we don't number it this way because it would take too long to get to a substituent. If we go this way, 1, 2, we automatically get to methyl right there. 3, 4, 5, 6, 7, 8, 9, and 10. All right, so we have to name the substituents alphabetically. So we're going to say here, B before anything else. B is on carbon number 5, so the location will be 5-butyl. It's on carbon number 5, 5-butyl. E is next, It is on carbon 6, so 6-ethyl. And now we have two methyl groups, M's. They're both on carbons 2 and 4. So you group them together. So 2, 4. 2 methyls means dimethyl. So dimethyl, all one word, undecane. So pretty ridiculous, long-ass name for this structure. This would be as difficult as it could be at any point right now. Okay? It's not going to go beyond this in terms of difficulty. When you get to organic, things like this will become everyday household names for you. You have to get to the point where it becomes comfortable to name a structure like this. But again, this is as difficult as it's going to get. We're going to see examples of naming other types of functional groups besides alkanes. But for right now, focus on the fundamentals in terms of this page.